The ability to block the electric current flow is known as electric resistance. Electric resistance is directly associated to the material electric resistivity, where resistivity can be low or high depending on the atomic structure of the material. The material or the device that opposes and resists the electric current is also called a resistor, isolator, or insulator. The common resistor comprises two passive terminals and resistive substance composed of an electric insulator with a very high resistance and poor conductivity placed between them. The resistor's terminal allow the electric current to passing through the resistive substance so it's reduced. An example about insulators is quartz, sulfur, mica, and rubber. By examining the atom's fundamental structure, the resistive substance and its structure may be recognized. More specifically, in resistive materials, the atom's final orbit, the valence shell, typically is full or nearly full of electrons. This indicates that these electrons are tightly bound to the atom and, as a result of their weak mobility, can hardly leave their positions when energy is applied. Because of that, the atom's chemical structure will have less cross links that will allow the transmitted electrons from passing when energy is applied, and hence, less electrons can pass freely. A material's resistance is determined by a number of factors, including, first, material resistivity, which is determined by the crystal structure and chemical composition of the material, how tight the electrons are bound to the atom. The lower the mobility would be, and hence the higher the resistivity. Also, as less the crosslinks found on the material structure that allow electrons from passing, as higher the resistivity would be. As a result, a higher amount of energy is necessary to move these electrons from one atom to another in such substances. Secondly, the geometrical structure formation. When the length of a material is increased, the material resistance increases, and when the cross-sectional area of that material is decreased, the material resistance increases and vice versa. Materials resistance is measured in ohm, while materials resistivity is measured in ohm per meter. That was the second element that has an effect on the electric circuit. The third element shall be introduced in the next episode. So ensure that you're subscribed and click the bell icon. Please help us by liking, commenting, and sharing. This encourages us to deliver more. Wait for the next video on the Electricity and Magnetism channel, and we'll see you next week.